In trigonometry, there are very few things that are very important. So I'll put them here for you to know how to study trigonometry. 1, you need to know angles. When we say angles, you should have an idea of reference angles, an idea of coterminal angles, now for this to happen well, you should understand what happens in quadrants. And once you understand what happens in quadrants, then you can understand what happens with the angles and how to obtain them. Then you can even do the solving now using identities. We just have a few which are important. One is sine squared x plus cos squared x is equal to 1. And then 2, compound identities. So if you know these, then you can easily solve equations. And then sketch. That's all. This is what we call trigonometry. So on Thursday, we'll be done. Because today we'll look at quadrants, reference, and coterminal angles. Tomorrow we'll look at identities and solving equations. Then, in fact, today we'll attempt some identities, and then tomorrow we'll finish up and solve, and then sketch the other day. So we start. We have degrees versus radians.
Sir, sorry, Panonofi, I want the previous page, just for seconds. Okay, thank you.
Thank you. So we have degrees versus radians. The relationship here is 180 degrees is equal to pi, and 360 degrees is equal to 2 pi. So conversion from degrees to radians, you multiply the given degrees by, let me change them because the by won't make sense. So let me use, say, multiply the given degrees by pi over 180. Two, from radians, to degrees multiply the given radians. Oh, don't the degrees. So what do I say? The given multiplied by 180 over pi, so that the pi's can cancel. What do we mean? One, convert the following to degrees. A pi over 3, B 3 pi over 2. Hello.
What's that from radians to degrees? Multiply what?
A pi by 180 over pi.
All right, thank you.
Okay. So let's do the conversion. We convert A. We are moving from radians to degrees. So we use this conversion here. So we'll say we are given pi over 3. We'll multiply it by 180 over pi. This is going to be, the pi's will cancel. And then 3 in itself, 1, 3 in 1 in 18, 6. So we get 60 degrees. We have converted. Is that being too fast?
No.
No.
Okay.
No, sir, it's okay.
Okay. B 3 pi over 2 will multiply by 180 over pi. So the pi's will cancel. And then 2 here, 1, 2 there, 9. 3 by 90, 270 degrees. C 4 pi over 3, you multiply by 180 over pi. The pi's will cancel. 3 here, 1, 3 there, 6. Altogether, we get 240 degrees. This is very, very important because sometimes your questions are given in radians. When you are studying, you understood everything in degrees. So you start by changing to degrees, which is what you understand, and then get the solutions, take them back to radians and present as your answers. This means that if a question is asked in degrees, it must be given in degrees. If the question is asked in radians, it must be answered in radians. No excuse. So that question 2 will be convert to radians given A 360, B 45, C negative 300. The solution For A, you say 360 multiplied by pi over 180. The previous board is here. Is that a screenshot? Okay, assuming it was a screenshot. Then you see that the zeros will cancel. 18 here, 1, 18 there, 2. Altogether, we have 2 pi. We have converted. B, 45 multiplied by pi over 180. 45 here, 1. 45 in 180, 4. We have converted. So that if it is negative, we don't care. So we don't care about the negative. We multiply by pi over 180. This here, and then 2 in 30, 2 in 30, 3 in 30, 10. Negative 10 pi over 3 in 18, 6. So we're still converting. 2 there, 5, and 2 in 6, 3. So we have converted. Those who just joined, they want the first board. This was the first board. Important things. We are on part 1, dealing with the angles. So we are trying to change them now. What if they're given in degrees? Can we move them to radians? What if they're given in radians? Can we move them to degrees? And this is what we have done.
Sir.
Hello.
Haven't you left something on C?
On C. Let's check.
Oh, okay, it's fine. I have C.
Good. Okay, so we go to the next page and do the quadrants now. Hello.
Check the previous board.
Sir.
Hello.
You can even use the 1 radius is equals to 57. When you're converting to which? To Celsius.
We have said that 1 pi, which is a radian, is equal to 180.
Okay.
That's a conversion.
I have a question on the first board.
On the first board?
Yes. You said the important things are reference angles and conterminal angles. So we've moved on to quadrants. So I've already done the reference angles and the conterminal angles.
We say that you can understand the reference and conterminal angles if you have the knowledge of quadrants.
Okay.
So you're here on quadrants to talk about the reference angles and conterminal angles.
All right.
How many quadrants do we have? Hello?
Yes, I have a question on converting. Let's say you've been just given 10 rads. How can you convert that, let's say, to degrees?
Where was it now? Here. If you are given 10 pi, and you are converting it to be 10 pi by 180, 10 pi by 180. So that this can go, and so you get this degrees.
Oh, yes, sir. Now let's say it doesn't have a pi. It's already in radians. Let's say it's just 10 radians, not 10 pi. Let's say it's already in radians. Let's say it's just 10 radians.
The pi is the radian.
In mathematics, what we
pi
call
is
pi
radian.
is the radian.
Oh, all right, sir. Thank you.
I don't know about physics. I haven't forgotten. Okay, let's talk about quadrants now. We have 4 quadrants from 0 to 90, or from 0 to pi over 2. So I've written both in radian and in degrees. This space here is called the first quadrant. Should I only put it up there? I may need to use some part. This is called the first. From 90 to 180 or to pi, it is called the second quadrant. From 180 to 270 or to 3 pi over 2, it is called the third quadrant. And from 270 to 360 degrees or to 2 pi is called the fourth quadrant. So we have only 4 quadrants. And the breakdowns are like that. From 0 to 90, acute angles. From 90 to 180. From 180 to 270. From 270 to 360. Angles that lies in the first quadrant are called reference angles. So before we talk about the reference angles, in the first quadrant, we know, or we must know, that sine, cosine, tan, sec, cosec, and cot are all positives here. You can get your calculator, punch any angle between 0 and 90, the response will be positive. But if you get an angle between 90 and 180, only sine and cosec will give you positives. The other angles, cos, tan, cot, and sec, in this quadrant, they'll be giving you negatives. In the third quadrant, only tan and cot will give you positives. The other angles, cos, sec, sine, cosec, these will give us negatives. In the fourth quadrant, only cos and sec will be positives. The other ones, sine, cosec, tan, and cot, will give us negatives. It must be clear to us that each trig ratio is positive only in 2 quadrants. Sine is positive in the first and second. Tan is positive in the first and third. Cos is positive in the first and fourth. And their reciprocals are positives where sine, cos, and tan are positives. Very, very important. From here now, the next thing is angles. These are the quadrants. And we've just obtained the information that in the first quadrant, all the trig ratios are positives. In the second, only sine and cosec are positives. In the third, only tan and cot. And in the fourth, only cos and sec. We have what we call but before we talk about special triangles, let's talk about coterminal angles. What are coterminal angles? Coterminal angles that share the same starting point and end point. They are called coterminal angles, and they have same properties because they fall or they lie in the same quadrants. Angles starting at the same point, they end at the same point, are called coterminal angles. If theta is greater than 360, to obtain a coterminal angle, or let's say to obtain coterminal angles, of theta, you subtract 360 from theta. And if theta is less than 0, to obtain coterminal angles, of theta, you add 360 to theta. The reference angles these are the angles that lie in the first quadrant. To obtain the reference angles, we have 4 ways of doing so. If X is the angle given and it lies in the first quadrant, its reference angle is the same X. If X lies in the first quadrant and you're looking for its reference angle, the reference angle of X will be the same X. But if X lies in the second quadrant and you're looking for theta, a reference angle of X, you subtract X from 180. That is, if the angle given lies in the second quadrant, to find a reference angle of that angle, you subtract the very angle from 180. In the third quadrant, you subtract 180 from the angle given if the angle given lies in the third quadrant. And in the fourth, you subtract from 360 the angle given. The idea is our answers must always be in the first quadrant.
So I don't understand from conterminal angles to reference angles.
Okay. Examples.
Just a minute, the previous board.
So the reference angles on this diagram, they are represented by Q.
By Q, yes.
All right, thank you.
So let me show you so that you understand.
Sir,
Hello.
why in the third quadrant you are subtracting X minus 180? Why not to be a 180 plus X?
That's a good question. Let's watch now. Find, I'll start with the reference angles. Find the reference angle of the following. A, to answer your question, reference angles lie in the first quadrant. If you add 180 plus anything, you cannot find an angle that is between 0 and 90. What you find above 180.
Sir,
Clear, thank you.
so what's the difference between conterminal and oh, okay. That's it.
A,
Bojo.
A, 70 degrees. B, 125. C, 225. D, 315. Solution. Find the reference angles of the following. A, theta is going to be equal to 70. Since 70 lies in the first quadrant, it is in between 0 and 90, so it's a reference angle of itself. B, theta, the 125x that we have lies in the second quadrant. For us to get an angle that lies in the first quadrant, that is between 0 and 90, we subtract from 180, we subtract 125. So we are going to get, what do we get?
$55.
55. C, the angle given is above 180, but less than 270. So we subtract from the angle given, we subtract 180. What do we get?
45.
45. 45 is in the first quadrant. G, theta is 360 minus 315.
45.
45. Now, let's find.
Sir, I have a question.
Okay.
What if you're told to find the reference
I have a
angle of a
question.
negative 60?
Okay, don't worry.
Can I ask?
Yes. You can
Hello,
ask.
sir.
I will answer the negative 60.
All right.
Another question?
The first one, sir, why didn't we not subtract from 180?
So that we get what angle? Suppose we subtracted from 180. 180 minus 70, you would get 110. This angle does not lie. This angle does not lie in this interval. All the reference angles lie between 0 and 90.
Sir,
Hello?
why didn't we subtract 90 minus 70?
Because 70 is already less than 90. We only subtract
All right, sir.
if the angle is beyond.
Okay, sir.
Okay. So because of time, let's just put E negative 60. What is a positive reference angle of negative 60?
Sir,
Hello?
we are kind of asking if you can give an example for contermino for both statements that you give.
Don't worry. Example 2, bon contermino, except that time is a bit running out. So let's do for negative 60. So for negative 60, you want a positive reference angle of negative 60. So you first find the coterminal angle of negative 60. So what is the coterminal angle of negative 60? We said when an angle is less than 0, to obtain the coterminal angles, you add 360. So since it's negative 60, we'll add 360 and get 300. The 300 we have falls in the fourth quadrant. So to find its reference angle, it will be 360 minus 300, which is equal to 60. So we have obtained the coterminal angle of negative 60.
So, sir, what if you just say the reference angle for negative 60 is 60? Can they give you a full mark?
No. The question paper actually have instructions that says show all the wiki. That too must be respected. Hello? That was a question?
Sir,
Hello?
so you are saying that when they give us a negative angle, always to just get the positive of it. But because we're subtracting it from, we'll subtract it from 360, and then again we'll do 360 minus that. Isn't it going to be giving us just the positive of that angle, which they'll be giving us in negative form?
Let's do for negative 120. For negative 120, the reference angle is negative. First, we get the coterminal angle. We add 360. What do we get? We get 240. And then obtain the reference angle of 240. So say 240 minus 180. And this is equal to 60. This is equal to 60. Have you seen that you don't just get the positive?
Proved.
Yes, sir.
So we immediately log back once we are cut.